Thank you, everybody, for joining us today. This is Coronavirus Bathroom Safety, Aerosols, and Transmission. This is a part of the BioRAFT EHS Community Connection webinar series, where we try to bring people from across the safety community together to focus on establishing and finding best practices, connecting, answering each other's questions, and feeling a little bit less alone in this heavily isolated world that we are all a part of right now. We have with us today Pierre Herckes and Jonathan Klane. They'll be our two panelists talking and sharing their information and knowledge. And I am very excited to have them on and have a lot of conversations where we talk about poop. So here we go. We'll just go in and have our two panelists introduce themselves and give a brief background about what they're coming from. And Pierre, if you wouldn't mind starting us off.
Sure. My name is Pierre Herckes. I'm professor of chemistry at Arizona State University. I do a lot of work related to clouds and aerosols. So clouds being liquid droplets in the air that suddenly got a very different dimension recently. We also do a lot of work on aerosol exposure in different professional settings, workplace settings. And so over the years, we did a lot of research on that. And then most recently, this got us to do research on masks, research on aerosol transmission and risks associated with the current COVID epidemic.
Great, and Jonathan?
Yeah, hi, I'm in a new role here at BioRAFT. I'm Director of Risk Management and Safety Education, so very outward facing, things like today, trying to help the community. But in the past, done a wide variety of things, was an embedded safety professional, basically Director of Safety at UC Davis College of Engineering and ASU College of Engineering, lots of other stuff, used to teach at a couple of colleges, etc. Lots of consulting. And my PhD that I'm hopefully going to finish here in a year or so at ASU is really focused on the intersection between sort of risk perceptions, human decision-making as one field, and the use of narrative stories and other forms of informal scientific communication and how they impact each other. So very much, I would say, on the social science side of things, human behavior.
Great. And just to make sure before we get started that we are all on the same page, because this is a very, I think, common thing that gets misreported in the science communication that goes out across the internet, that we'll be talking sometimes about the presence of COVID RNA or coronavirus virus, SARS-CoV-2, that the presence of RNA does not necessarily mean that virus is present or that live virus is present or that live virus in enough quantities to cause an infection is actually present. And that is a common thing that I think gets too heavily just drawn upon and easy point of confusion. So for the folks who may be a little bit less familiar with those distinctions, just a good place to come together. All right, well, Jonathan, Pierre, do you want to get things started? I know that we have these sort of two big buckets to talk about today. On one hand, discussing the areas of potential bathroom risk. We have those over down here in the corner just to help everybody stay focused. Then we can move on to how we might evaluate different variables around bathroom safety.
Pierre, do you want to start by kind of summarizing where a lot of this scientific literature really is? Is that a good place, do you think?
Sure, yeah. I can start by talking about that, and I can use some of the bullet points here on the slide also to support that. Very first thing is that we know there are many unknowns. So a big thing is that there's still a lot of things that we don't perfectly know. And so we know that there could be risks, but very often we don't even know really how big these risks would be. And so if you think about going to the bathroom, I mean, what could be potential risks? And so the first one could be, you go in the stall, maybe you do your business and maybe you can generate aerosols. And so a big first concern is that there could be toilet plume aerosol particles. What is that? That is when you actually flush the toilet without a lid on, you actually aerosolize particles. You generate some small droplets and then small droplets towards these aerosols of only a few microns, some even smaller than that, by the action of flushing. If you think about public restrooms do not have, they do not have lids. And so you aerosolize some of the materials. And so that is out there in the literature for years already, that there are these toilet plumes that are generated and that have the potential to transmit diseases. In the case of COVID or SARS-CoV-2 virus, we know that in sick people that their poop contains virus. Some of the virus might be viable, some of it might not be viable. I mean, there's a range of observations on the viability of these viruses in the literature, but there's definitely a concern that as you go to the bathroom, you could generate some of these particles. Again, we promised you a very appetizing discussion here. I hope not too many of you are taking this during their lunch breaks. But yeah, basically poop aerosolization is out there and is possible. Of course, we don't know yet really to what extent this also applies to COVID patients. Then the next stage would be, well, after you are done, you might actually wash your hands. And so as you wash your hands, you're gonna use something to clean, to dry your hands, and most places have dryers. So another big concern could be then, as you dry your hands with one of these blowers, I mean, they have these fantastic high power blowers now, but what they are doing, as you do it, you already see that the water gets, taken off your hands as, again, aerosols and droplets that go up in the air. The larger ones, of course, fall down rather quickly. The smaller ones fall down less quickly. And so there is a concern that if you would have virus on your hands, now you actually get the virus airborne in that process. Again, we know that we don't know everything on that. We think right now this might not be the biggest risk because, I mean, typically you wash diligently your hands with soap, and the soap is supposed to actually damage the virus, make it unviable, and should be very efficient, which is why at least initially so much focus was then, or just wash your hands with soap. Still, there is a residual risk there that you could get particles airborne like that. Beside this, there's of course a risk of surfaces, any kind of contamination that goes to surfaces that you touch. You can think there about people touching, I mean, you touch the faucets, you touch maybe the fan, you touch the door, you touch whatever is there to flush the toilet. And you might touch it with the hand, somebody else might do acrobatics and touch it with the foot. And so you don't know that. So there is a risk of transmission also just by touch, particularly if later on you touch your hands. And so then another potential bathroom risk is that seems less apparent, is that when we go to the bathroom, we know that if you go in the stall, it's kind of a quiet moment. And you're all by yourself. And so there is actually a big risk in terms of human behavior that as you go in the bathroom and you close that stall, that seems like a great opportunity to take off that pesky mask that you were wearing all morning. Of course, when you work in a larger office or so, you're around people all the time, you don't get a break from your mask. And so there is a risk that very many people take a break from the mask when they are in the stall. And so there is a double concern. There is the concern that, well, if the person is infected, they might cough, they might breathe out these particles. So we lose the benefit of releasing particles, but we also lose the benefit of actually inhaling particles, preventing that with the mask. And so this is kind of a behavior aspect of that, maybe we go to the bathroom and we take advantage of that. And we got to this idea because if you think back about smoking and if you forbade, I mean, we knew that when we were forbidding people to smoke, what did people do? They went to the bathroom to light a cigarette because again, you wouldn't see it. And so there is this concern that this might be happening. And so like this generate a larger exposure to people in that environment.
Yeah, that's very funny. It's so common to some of the topics we've touched on before, where when it comes to COVID risk and lab safety, often the bigger risks are actually from the experiments and the things that people are working with, but you get so hyper-focused on toilet plumes and aerosols that you sort of look past some of the bigger behavior-based risks that might be present.
Yeah.
You want me to jump in, Matt?
Oh, yeah, please.
Okay, great. Yeah. No, that was great, Pierre. It covered a lot of ground. So, I mean, piggybacking on what Pierre has laid out for us, I was trying to wrap my brain around this whole subject, which is a little bit tricky in many ways, not just the fact that it's poop, right? It's like, that's fine. As someone posted in our chat, that book for kids, I think it is, Everybody Poops or something like that. Sounds like it's very, very good for our talk today. So Steve Covey says, begin with the end in mind, right? If you remember his 7 habits. And I like him a lot. I like his stuff, not just because he and I, go to the same barber, as it were. But what's the end in mind, I think, for all of us here today is greater clarity, right? To understand this better. And I think that, our goal, the three of us, we've talked a lot about this, that is our goal. We want to help everyone achieve greater clarity. But in my head, the sort of metaphor or saying that comes to mind is, at the end of this, there's so many different factors, so many differences that Pierre has, started to really mention here, type of bathroom, size of bathroom, who's in the bathroom, are they taking off their masks, are they talking, are they singing, are they talking into their phone? The person opening the door with their foot came from a story from me just the other day, where I saw a guy at my previous workplace over years, many times use his foot to open the men's room door. It was one of those lever doors. So I'm like, I am never touching that door handle again in my life. So I think at the end of this, you're going to say, this subject now is really clear as mud, clear as raw sewage, really, because there's just so much packed into it. And the pun was obviously intended there. But look, don't despair. I think throughout the next hour-ish, we're really going to try to hammer away at what a lot of these differences are. A lot of it, I think the three of us and many of us would agree, fall out as risk factors. And how do we properly assess risk? Risk is in the details, right? So a couple of, quick sort of things in all. How do we make this link? We all know that for something to get in the air and then become a problem, there's got to be a source of what that pollutant is. We'll just call it that for short. A pathway and a receiver, right? And then how does that affect the receiver, right? And it can be in different ways depending upon route of entry into the body, right? It's fine to eat all of the butterscotch flavoring, including diacetyl, that you want, but if you breathe in a lot of that, a lot of us know that's a real problem. So route of entry, maybe state of matter, really matters. That's what I was trying to get at. So just as Matt was getting at, just because we can detect viral particles, RNA particles or whatever, does not necessarily mean there's enough for it to be viable, a viral load. How much of that gets into the air plume that Pierre was describing? How does that transmit? How much of it hangs around? There have been good studies, including in the links that Matt has posted, including tests over 15 minutes after a flush from a high energy toilet, where they're showing a couple of 100,000 aerosolized micro droplets, as Pierre was mentioning. still in the air, but then is that staying in the stall? Is it getting out into the main area? If someone just pooped, if they've got diarrhea, which is a lot of the testing in the hospitals has been around, am I coming into the bathroom directly behind that person if it's one person at a time? I mean, quickly you see that our brains just become overloaded, right, with so many risk factors. And what do we and the people we work for and seek to help want to know? Am I safe? Am I not safe? And it's, you know, just so complicated. So that's really, I think, a lot of where I come at this. And Pierre and Matt and I have had some really wonderful talks. I think all of us really come at this from this perspective of there is a lot to talk about here. So look forward to it. Look forward to your questions in the Q&A too.
Yeah, particularly because of the breadth of this subject, there are so many kind of known unknowns, being aware of the fact that, you know, again, these toilet plumes and aerosol particles are everywhere, but do they actually contain intact virus that is capable of infection? And then, of course, do they contain enough of a viral load to cause a transmission or infection? Are very challenging questions to answer. So we'll be focusing on sort of the things that we can speak more confidently about, and definitely please point us to the things that you're interested in the Q&A. There are opportunities for you to have back and forth conversations without us addressing the specific questions, so that way it's not all kind of bottlenecked at just what we're talking about as well. So one thing that we haven't chatted about yet is this concern that there may be transmission of viral particles and aerosols through plumbing across multiple floors. I know this is something that has come up in certain cases. That came, I think, Jonathan, you mentioned in one of our earlier conversations, where's that smell coming from? And, you know, instances where things get flushed down the sink and then show up in places that are surprisingly far away within a building, especially, you know, in the context of a dormitory where you have a large plumbing system in heavy use, whether that might be a concern. Could you speak to that a little bit in terms of what you learned in that area?
Well, did you want me to start? I mean,
oh, yeah, sure, go ahead.
Yeah, sure. So this has been looked at. I think it was the Amoy apartments, right, in Hong Kong, that piece by Kang et al. And then there was a recent article about that. And basically what they found is through a very specific design of this multi-story building, and there's been a couple of other instances as well that I hope Pierre will also chime in on afterwards, where they believe, it's hard to really prove, but there's a good belief that what happened is through dry, we would call them P-traps in the secondary article, he referred to them as U-traps, but I think we all know what we're talking about. We've done enough odor chasing that we always ask, are the floor drains, are the sink drains full of water to stop it? And they had some that dried out. They had these floor drains in the bathrooms in the apartments. And what they hypothesize and believe is that, yes, there was a large number and there were fatalities from it in the Amoy apartments. Now, this is going back to the SARS epidemic, as I recall. And if I've got details wrong, guys, please correct me. And I think it's a good article or a couple of journal pieces to really look at for folk. I'll let Pierre pick up on it. The one thing or two things I'll mention real briefly in a similar way about air movement through buildings, and I think a lot of us really know this, is at a previous institution in a lab that Pierre happens to know, so that's a hint, a researcher poured some bleach-containing solution down a sink. Inappropriate, was not to be done, did it innocently anyway. It went down the sink, but the vapors traveled upwards 2 floors, came out in a laboratory above them and caused the evacuation of that lab because of the strength of the concentration of the hypochlorite, right, in the air. And then wrap up with this one. It's from years ago. The air quality manufacturer, TSI, had a good article about an investigation of carbon monoxide exposures in a very large office building. There was a gentleman in his office randomly would complain of headaches. They started to do investigations. long story short, only through a TSI meter, particle counter, as it turned out, I have no connection with them, they discovered that the carbon monoxide and, of course, the diesel particulate matter, how they could detect particles, were actually coming out through the very narrow electrical conduit. So not through the air intakes whatsoever, but electrical conduit is supposed to be plugged, supposed to be sealed, right, at the garage end. And the garage, which was way, way away from this guy's office, there was enough air pressure and pressure difference that it was actually traveling through the conduit, through not miles, of course, but hundreds and hundreds of feet of conduit and getting out into his office. So all of these are, I think, good illustrations of air will find a way, least resistance, pressure differences, and sometimes we can be very surprised by how that might play out. Pierre?
Yeah, is there anything that you'd like to add? Or
yeah, I mean, Jonathan covered this very, very completely already. Yeah, I mean, there were these documented cases on wastewater to air. Again, a lot of this aerosolization that happens in the toilet or that might happen in the conduits, actually, as the water moves, can generate these very small aerosol particles that are only a few micron in size and that have these lifetimes of hours, sometimes days. And so now you have something that nearly moves around like a gas phase compound. I mean, nearly, I mean, not quite, but nearly. And if you think back about all these transport issues like Jonathan showed with the bleach, or the example he gave with carbon monoxide and actually the diesel particulates. So now you might have similar transport mechanisms for aerosols that actually carry the virus. And so you can have then very exotic transmission pathways. This is probably not the most common, but there are documented cases out there, if not for SARS, for COVID right now, definitely from SARS before, but even I think for COVID now there are case studies that showed some of these things. It might be rare, but it shows part of that difficulty that in assessing these things, that it's something that can happen. So there is no 100% totally safe. I mean, there are these little bit freak things that can occur that most of you are familiar with from your own experience. And then it brings kind of the next thing that really for anything aerosol related, the ventilation really is critical. And so that then depends a lot on a case by case on how well the bathroom is ventilated. And on some of our buildings, we actually might need to think about even if the bathroom is ventilated very strongly, where does the air go? Because in a lot of buildings, up to 90% for energy savings. I mean, I'm in Arizona, like you see from my background. So here the buildings are quite well sealed, and new buildings, typically 90% of the air is recirculated. And it's not necessarily sure that there are filters in between. And so you take the air from the bathroom and you recirculate it into the office next door, and so on. And again, some of the particles might actually be able to travel. And so there is some potential risk there to consider.
Yeah, Pierre, and I think that speaks very strongly to your point earlier about mask wearing in bathrooms. And we have a comment or a question down here from somebody, Steve, asking about cloth masks not protecting the wearer. So does taking it off in the bathroom make a difference? So in terms of protecting yourself, probably not too much in a bathroom, particularly where you're having toilet flushes and larger droplets be created. I would imagine that, breathing in through a mask would catch a few of those droplets rather than giving them a straight path into your mouth. But the bigger thing is really, I think, how much of, if you are infected and you are shedding virus, if you're wearing a mask, you are catching a lot of that viral load in the mask and preventing it from going into the general atmosphere and recirculating and potentially infecting somebody else. And that, especially if that air gets recirculated somewhere else in the building, that can make a potentially big difference.
Yeah, there's so much that we could go down, so many different rabbit trails here. I will just, politely say that the link to the aerosol FAQs that Pierre provided, that we have, is really fascinating. I spent quite a bit of time yesterday reading all of it. It was an interesting read. Pierre did not put me to sleep or anything like that. I was really intrigued by a lot of it, you know, and really, to be honest, only some of it, you know, did I know. There's a tremendous amount of detail that really goes into that. So on this issue of mask wearing, risk is in the details. You know, go to that source. It's a really good one. They've done a good job of curating research and talking about it in a good way. Multiple layers, of course, can be much better. Different types of material can be much better. I'm not aware of fabric being very much a one-way filter mechanism. So I think there's a little bit of equalness to how much it's protecting in either of the two directions, and a whole lot of details about the fit. So I'll just say to wrap up on this one, I don't know how many bathrooms, public bathrooms I've been in, you know, during COVID-19. And the bathroom I was using back at my previous institution, not many of us were in the building, but there were some, and, you know, most wore their masks. There were some that did not wear their masks. I did wear my mask and kept it on regardless, you know, because why not? It's a really good habit. And that was just important, you know, and the guy in the stall doing his business, talking rather loudly on the phone, sounded like he did not have his mask on. So go in, luckily as a guy, you know, go to the urinal farthest away, or if it looks particularly bad, forget it. I'm going down the hall to the other restroom for a variety of reasons, and using that one, and go in, do what I can, don't talk, wash my hands, don't touch the knob, get out. And, you know, maybe that's just the best advice I can give.
Great. So we are gonna keep on moving here. And just a reminder to everyone, looks like a lot of you have already found our Q&A box, but we will be referencing that in the live Q&A in about 10 or 15 minutes here. So you can find that in your Zoom control panel. It's a great place. You can go ahead and thumbs up the questions you're most interested in, so we know what to address with the highest priority. And you also have the ability to comment on each other's questions with resources, information, further questions, clarification. It's a great way to spread information more, not just rely on us to speak about something you'd like to talk more about. So getting over to this other side of evaluating bathroom risk, you know, we've talked a little bit about where some of these risks might be coming from and the realities of them. But what are those variables that are the things that you want to think about when you're either in a position where you're setting a bathroom policy, trying to enforce and ensure that other people are going to be safe using the bathrooms at your organization, or just personally, if you're out and about and you think, okay, well, I've got to go, but can I feel comfortable doing this? Like, what are those things that you look for as indicators of maybe a safer or a less safe bathroom? Pierre, would you like to kick us off? Anything kind of biggest on your mind?
Yeah, it might be a little bit repetitive here, but the real critical thing really is ventilation. Anytime you have air transmission, aerosols, anything in the air, it's a matter of ventilation. For COVID, we know that the single virus, inhaling it probably will not get you sick. So there is a critical amount that you need to inhale. And so like with any pollution, the solution to pollution is dilution. And so it will help you if you dilute, and that means ventilation. And so, and therefore it's very difficult to speak in very general terms about bathrooms. It's just because they come in such a large variety. I saw in the Q&A people already asking high pressure toilets or so the toilet itself changes, the size of the stall changes, and then ventilation. And ventilation is really, really a critical item. On a silly individual protection way, you could probably trust your nose a little bit in terms of ventilation. So if you go to a place where, suddenly you still can smell that somebody just did something, well, chances are that actually there might also be aerosols not very well vented in that area. And so you could, as a user in the first approach, you could look at this. For a policy approach or so, it would be really important to think about maximizing ventilation.
And then, of course, you have other elements such as single or multiple use occupancy, just knowing if there are going to be multiple people going in and using those spaces or not at the same time can really change that. I also looked for masks very heavily myself and kind of reminding people, maybe a little sign that says, thinking about some mask-free time, think again, reminding people that that is a big risk and that, it's better. You'll be a lot happier taking your mask off outside than in a bathroom anyway.
I think it's well covered. I don't really have other risk factors. I think, as Pierre said, ventilation is certainly way up there. I guess I'll just add briefly, human behavior is very problematic. I saw a question in the Q&A, what about people who don't wash their hands really well? And so Pierre, Matt, and I were chit-chatting a lot this last week or so. And, one of the things that we've reflected on is, look, there's factors that we cannot control. I cannot control the ventilation in a public restroom unless there's a window available. Sometimes there is, right? But a lot of times there isn't. And I can't do anything about that. So I don't, necessarily focus on it. If I've got to use a bathroom, I'm probably going to use the bathroom and hopefully get in, get out, and trust that part of the science is amount of time exposed to anything. And so I take, I don't know what the word is, a good feeling in that I'm not spending a lot of time in there. So if you're familiar with some of the studies that indicate that we guys seem to spend more time doing our business than the ladies do, this might be a good reason not to, to get in, do your business or whatever, and get out again. But the things within my control, which we all love, we all know that, what's within my control I like. So that's the, what my habits are. And that includes that I'm going to wash my hands and I'm going to be careful about this. And maybe I'll choose a different bathroom. Maybe, hey, it's a nice day for a walk. I'm going to the building next door. I'm going up a couple of flights of stairs. So there's a lot that we can do ourselves. And I know that doesn't solve all of our problems because all of us are responsible for a lot of people, but then we can really have these conversations and encourage people to think in terms of the risk factors for themselves. And as I think both Matt and Pierre have said, the risk factors for other people, and see if we can't move forward on safety culture at the same time.
It does seem like the biggest concerns here really are those behavior-based ones, mask wearing, hand washing, good hygiene, and then to some extent, again, like John mentioned, ventilation. And for the most part, bathrooms aren't the riskiest places. There are places where you're not lingering for too long. Frequently, they will have ventilation, which is more than many other rooms might have. And, I think we're diving into all these things because there have been these very sensationalized articles talking about toilet plumes and aerosols and transmission and multi-floor plumbing, pressurized dispersal of droplets. But that for the most part, this doesn't seem to be really where COVID is being caught and where it's being transmitted. And just a good thing to maybe not focus on too heavily. Pierre, you had something to say?
Yeah, no, this exactly, I think, looking at the Q&A, the top question on top, this really goes to that. There were no big outbreaks in a public room, a public restroom reported. There are these case studies that documented, if this is the cases in the multi-storage buildings where it jumped from one floor to the other through the bathroom, through the drains. And there is a recent case that that has pretty strong evidence that on actually one of the evacuation flight, the person got infected by using the bathroom. And actually that case, that was the only moment where that person admitted that they did not wear an N95 mask. So there are more of these anecdotal evidences than really serious evidences of outbreaks. However, we also need to keep in mind that even if the bathroom would cause an outbreak, let's say in a workplace, you would probably not realize that because the same people also have other contacts. Like if it's a workplace or a university or so bathroom, it tends to be used by the same community. And so it could just be a part of the community outbreak. So you wouldn't necessarily trace it to that. If it is a true public bathroom in a park or so, you would never be able to trace the people later on, anything like that. So, but still, I mean, this is probably, I mean, there are no big outbreaks known on that. And as both Matt and Jonathan said, there's probably very little risk because again, just think about, we are now 6 months, over 6 months with the virus, and how many of us have used public bathrooms and how often. And that gives you also kind of an indirect feeling of risk. If it would, the risk would be very high by now, just by the probability and how often we did this thing, we would see more of it.
Absolutely. And I love that as a position and a spot to transition over to our live Q&A here. There are a lot of questions and I'm excited to see more of them. So I'll give everybody who has been listening a chance to go into the Q&A, ask their questions, also take a look through, thumbs up things you're interested in, but feel free to respond to each other's questions with your own information, experiences, or clarifying questions. It's one of the things that I love most about these webinars is just the side conversations that happen. And in the meantime, while everybody is getting accommodated here, I'm going to launch a quick poll for everybody to participate in. So we are trying to keep these webinars going. They've been going since May, and these are the community connection webinars, and we rely on you, our community, to help keep them going. Knowing what topics are most interesting to you, whether or not you might be interested in being a panelist for these webinars to help share your information when there's a topic that lines up with your experience is just really great to know. Whether or not you see one of them on the list, just being able to tap into all the expertise we have in our audience right now is really helpful. And again, sometimes the most important thing is just having a place for everybody to get together and talk about a particular subject. We've definitely heard about several people here coming and making really valuable connections from the chats going forward to share information. So I will go ahead and leave this poll up. If anybody is interested in being a panelist or you have somebody in your network who might be a good fit, please let me know. And I'll reach out to you after the webinar and we can chat and figure something out. All right, so going over to our live Q&A here. The first question here is from Marcus asking, the water saving technology of newer toilets appears to use more flush pressure using air. Higher flush pressure appears to generate more splash and potentially flying stuff. Is there acceptable splash versus unacceptable splash or airborne generation? So it sounds like just sort of asking about different models of toilets and standards of acceptable risk when it comes to particles and droplets.
I can give it a try. It's part of the, let's just call it the known unknowns. What is well documented. So some researchers, particularly a person by the name of Chuck Gerber from the University of Arizona, they looked a lot at this some 10-ish years ago, also because of hospitals and so on, and infectious diseases. And they saw that, I mean, one thing is the pressure, but the other thing is also the overall toilet designs. There are all kinds of bowl designs, there are all kinds of pressure or so. And so unfortunately, the non-answer I have to give is, it is documented that depending on the toilet, there are huge differences in how many particles you generate, easily a factor of 10. That's in some of Gerber's papers, in terms of number of particles that you generate. And so, yes, there's probably a huge difference, but imagine that, I mean, you're safety professionals, most of you might not have heard even about toilet plumes. So there are no standards on toilet plumes or so, because the only standards really are on water use. And then of course, everything is optimized for maximum flushing result, but not, how to say, the flushing is never optimized for minimum aerosol generation. And for all these aerosols, you have to consider that even in these older works, these 10 years old, the solution was always just close the lid before flushing, and it will solve really most of the problem, because except immediately opening the lid again, most of the particles will actually end up depositing. It is just that in public bathrooms, you do not have lids.
Yeah, the only sort of related topic, Gerba and fellow researcher have done a good job of, as well as about a dozen others across the globe, studying the opposite end of the pipe from the toilet and trying to identify outbreaks and clusters before they occur too badly by doing sampling of the sewage for defined areas. So they were doing it at University of Arizona for one of the dormitories, and they did spot in the results and then discovered through testing that there were a couple of students who were positive but asymptomatic. So something to think about of some of these other benefits. I know it's ancillary to this question, Marcus. The other thing I was going to quickly say is, again, semi-related, is how do we get the poop down, right? The toilet, and that's usually with a lot of water and pressure, and you get the plume. And I don't know if any of you are fans of Science Friday, but last Friday or the Friday before, he was interviewing a researcher who is designing a coating for the inside of the bowl. As Pierre's getting at, there's all sorts of different bowls and bowl designs, and coming up with a coating where, basically, long story short, you can use half of the water that you normally would to have the poop go down without it adhering to the bowl. And so you might want to look that one up, and there's still a lot of work that needs to be done. But if they can do that, then hopefully you're going to get less of the turbulence and the aerosolization coming up.
Yeah, and it really doesn't seem right now like there are those sorts of standards in place for measuring, understanding, or just sort of what's acceptable in those spots. So at least, hopefully, that's something where if it really were truly urgent, that would have been identified and addressed by now. Certainly not a guarantee, but I think, Pierre, you made a great point that just at this point, we've been in it for 6 months, and that if bathrooms and toilets were a major source of infection, that hopefully our contact tracing would be capable enough to identify that. Great, so yeah, we have this question here from Joan asking if there are any studies to date that show outbreak of disease linked to public bathrooms in regards to SARS-CoV-2. So I'm gonna go ahead and just click on this link, and oh, okay, it's waiting for it to load. I'm gonna show it to everybody here before we move along, but just wanted to let everybody know that this one's out here. It's in the chat. I can go ahead and grab that and pop it into the chat as well. It's in our Q&A, and we can get this added to our online list of resources as well. I don't believe, yes, there are a lot on our list right now. I'll have to double check to make sure I'm not double posting something. But Sabrina, thank you so much for sharing this with us. If anybody else has any resources that they like, I know I believe Lisa sent me some things before this webinar that I'd like to get up about hand dryers. So thank you again for participating. We really appreciate the help here. Great, next question here is from Lisa, different Lisa, asking, can you address the risk to custodians or other staff cleaning public bathrooms?
I'll jump in to start, I guess, and Pierre, you can follow up with whatever you'd like. I think that's a great question. What is the risk and how much flushing are they doing? When you think about it, in the past, maybe people would think, okay, I've got to flush. Might not be the best thing to do is to be standing directly over it while you're flushing it. And the aerosolization, again, it depends on how much. So it could be that they are a higher risk group, which I think is what Lisa's really getting at. They're doing this much more frequently. Not every person does a really great job. Maybe it gets clogged or whatever the case. So now it really, I think, comes back to some real basic, health and safety that we do. How do we develop the protections for them? go through that hierarchy. But of course, at the bottom end of it, we're going to look at personal protective equipment, might want them to be outfitted with N95s in this case, might want them to be using face shields when and if they're trying to plunge or, you know, keep flushing or, you know, whatever the case may be. So I think it's a good question, and I think it, to an extent, comes down to very classic occupational health and safety. Pierre?
Yeah, I mean, I completely agree. I mean, they are definitely at a higher risk than the average person, just because they are there longer, just because of the actions they are taking, the unplugging, the flushing, the cleaning. I mean, obviously they're already wearing gloves, and normally they're also already wearing masks. And again, and that might just be my personal pet peeve or so, I think an important thing would be to communicate to custodial staff is just to let them know that there is a real risk, and to be sure that many of them do their work in the evening hours when they are alone, sometimes the only ones in the building. And I mean, masks are not the most comfortable thing. And so there could be a temptation to actually not wear masks, or why would they be wearing masks? And I think they definitely should have masks, and they should understand why they should protect themselves. It's again more of a behavior thing than anything else, because again, this will be people that largely work by themselves, all isolated. So there is nobody there to check on them. There's no peer pressure to wear a mask.
Great. And then just to kind of dovetail that into another question that I think got bumped a little bit here. Tiana was wondering what are some additional requirements or considerations for those custodial maintenance plumbers that may need to unplug toilets, specifically of sick persons, for example, at a residence building, or somebody who may be under quarantine. Are additional respirators and maybe other protections required? So just wanted to make sure we adjust that there, just kind of knowing ahead of time, okay, this is going to be the toilet or something of use from somebody who does, you know, have COVID. Would you treat that differently, or would that just sort of have the same kind of precautions?
I would agree at what they're getting at. The risk sounds to be increased, so the protective measures have to follow along with that. And, you know, I think in terms, even though it's maybe in the home environment, but they're known to be sick, people could look toward the added protections, including PPE, that are used more commonly in your healthcare environments because of what this person is getting at. And so they might need to wear some type of either gown or disposable whole body covering or whatever. I mean, I think it depends on the task that they're doing. Custodian will be doing probably a different task from a plumber, et cetera. But I do agree that if we have some knowledge that they're sick with the virus itself, then yeah, you do have to up your game on your protective measures.
Yeah, I totally agree. I mean, if you think about having a plumber having to deal with, let's say, a plugged toilet of somebody who has COVID, I mean, basically the working conditions are the same with aerosolized body fluids than a doctor doing an intubation. Not quite the same, how to say, viron concentrations airborne, but still the same kind of risk. And so I think for the least N95 masks, ideally eye protection, of course, contact protection, gloves or so, and a one-way apron. I mean, a one-way disposable apron, I think, would be appropriate to that. I mean, basically, you put them in the same situation dealing with the body fluids of a sick person than medical stuff. And so they are basically, if you know that the person has COVID, you should, I mean, the plumber or even the custodial staff basically should have the same precaution than it would be in a medical setting. And in a sense, many dormitory rooms where you actually isolate some of those people, you have to see that you're in a situation like in a quarantine room in a hospital. I mean, you have a sick person, and so it's appropriate to use the same protective gear.
Fantastic, great. And I'm going to move on to our next question here. I don't know where the hour went, but it sure is moving by quickly here.
Yeah.
Question from different Lisa here, asking, with hand dryers, warm air hand dryers and jet air hand dryers, there's an assumption that the person washed their hands appropriately. But what about users who didn't wash their hands properly and use dryers? I think we spoke about that a little bit earlier in the topic or in the conversation, but she followed up to ask, could you address in terms of risk of aerosols produced by the dryers that have potential to be infectious, especially earlier studies with bacteria and bacteriophage? So certainly there's been a lot of research done on these aerosol or on these hand dryers spreading droplets and aerosols before SARS-CoV-2 came around. Is there anything that comes to mind in terms of research? Or of course, also asking to our audience, this is one of the times that I love the most about these webinars. We don't know everything. We have a fantastic group of people here, over 200 of you, safety professionals. Please feel free to chime in with your own experience and resources and really get that information sharing going. But I'll open the question up to our panelists now.
Pierre, do you want to tackle this one?
I can give it a shot, but some of these things are, again, the known unknowns.
Mm-hmm.
The unknown part of this is because the aerosol generation very strongly depends on what people actually do. If you take your hands and you shake them out like that, you mostly generate very large particles. A low flow air dryer also will mostly generate large particles. Large particles means large droplets. Think, I really love for these larger things the term ballistic, so they actually settle relatively quickly, so you get less of the aerosolized smaller particles. However, if you take, let's call them Dyson or so, really high, high pressure, high flow, very sophisticated dryers, you probably generate more of the smaller particles that will aerosols that stay around longer. Now, part of the issue is, and this boils down to the very first thing that Matt said today, is this issue. A lot of these studies look at DNA, or in the case of viruses, RNA. And so you actually see that RNA like this is distributed, but we actually don't know in all the cases if it's viable. So even if you aerosolize with a hot dryer, if the viruses or bacteria that you aerosolized, it's not always clear that these things still are viable. Particularly, it seems that SARS-CoV-2 is not the most resistant virus, and so it is possible that heat or so helps to actually minimize this way of transmission. But again, there is very little, we know very little about that. We barely have information on how many droplets and what size of droplets and aerosols are generated. And there's pretty much no information out there for coronaviruses if they survive this and if they are happy viable. And like this is a transmission pathway.
Great. And just to get to one last question before we hit our 3 p.m. mark, which we may be able to go over with the availability of our panelists, I wanted to jump to one question that really kind of called out to me. Do you have any suggestions on how we can have effective conversations with our custodial personnel who typically are the lowest paid workers? We depend on them as first line workers and take credit for their cleaning and disinfection. These are the people who we spoke about earlier on the ground, scrubbing into the bathrooms, cleaning the toilets of the people who may be sick or infected, and also unfortunately have that connection of maybe lower level of education or understanding of the risks and higher levels of exposure. So maybe Jonathan, have you found that there are any particular sort of strategies or resources that help to make that connection and have better conversations with these people to help keep them safe?
Yeah, sure. Thanks, Matt. When I was at my last 2 institutions, I was an embedded safety professional, and I got to know the custodians at both places. Needless to say, back at ASU, where I was for 7 years, I got to know the ones in our building really, really well. And, I think the more we can get to know people so they get to know us and trust us, and we can develop relationships. And that was in a Shima Cafe conversation. I think Victor Means posted about the benefits of developing strong relationships with the people around us. And I wanted to give credit to him for that. I think it's really critical. And then, hopefully they will get used to coming to you for advice. So back there, we had a very sad case. I don't want to go into the details, but one of the custodians came to me and said, I need red bags and how to clean up for, and I really don't want to get into what it was. It was horrible. And I said, why, Tony, why do you need that? And he told me. And so developing these strong relationships, developing trust and relatability, and then just speaking very honestly. I never speak down, but I speak, in just very, very, very plain language. So the last thing I'll say, and then have Pierre chime in as well, is we all suffer. We all suffer from what is called the curse of knowledge. So as I start to, we talk about SARS-CoV-2, and we talk about RNA and particles, and, just all sorts of techno jargon, acronyms, etc. A lot of us speak a lot of the same language. We know mostly what we mean by that. But if we can speak in regular terms, very, very easy terms, without using any of our known jargon, it's a challenge. We'll also do better. So I think those are a couple of good ways of really strengthening that bond with them. But Pierre probably has some added things to add to that.
No, I think this is great. Again, I don't have this kind of professional experience, but sometimes I think one way of also trying to illustrate this, many of the custodial staff, they know that toilets splash. I mean, for them, it's not a surprise that if somebody flushes, something goes out, because they know the floor gets wet and they know they got wet. I'm sure many of them, when they cleaned, particularly all the bathrooms that have like the infrared little sensors to actually flush the toilet, I'm sure every shift or so they might actually get wet. And so to relate to what they know is that, look, the things splash, to explain that there are also things that they splash also particles that they don't see, and therefore they can protect themselves with a mask, might be an approach that can help. Because I mean, they know toilet splash, because I mean, they are the ones that clean it up. And it is just to make this link, they are the parts that you actually visually see, but then there are the things that you don't see. And to protect you against what you don't see, a mask can help.
Can I add a really quick resource? You asked for resources,
Yeah,
Matt.
of course.
So again, the FAQs on aerosols that Pierre shared were really great. And I encourage you to either read it or at least scroll through. And they have some really great analogies and metaphors and similarities. And they have some wonderful graphics that really illustrate some good visuals, et cetera, infographics, et cetera, charts, graphs, that really do a good job of explaining a lot of this. So you all may find some of those as really good resources. And these were put together by aerosol scientists and engineers, very similar to Pierre and a lot of the people who have done the studies in all of these journal articles that we're citing.
Yeah, and of course, those resources will just hopefully serve as a good jumping off point into all of these different areas of study with all of the references and everything. We can't, of course, maintain a active, most up-to-date library, but we are trying to make sure that we are arming you with any information that we can get to you that will help you keep everybody safe. And we are, wow, a little bit over time here. We do ask our panelists if they're able to stay on for an extra 15 minutes just to keep answering questions. We still have a ton here in the Q&A. And also just a quick plug for our next coming up webinars. 2 weeks, we'll be talking about getting EHS a better seat at the table, just how health and safety professionals can be involved in decision-making at organizations, since nearly every decision that gets made now is a safety decision, like bathroom policies, for example. Then we'll talk about delivering engaging training, especially when everybody is so taxed on their attention and still need to be trained now remotely. And our newest one talking about triaging chemical safety inventory and responsibilities when resources are taxed. And I know we've had this up for a little while. I'm sure some of you have gone over to Menti and entered this code, but let's take another look at our little wall here of information, sort of advice to past selves. So I'll keep this up for a bit and let everybody look at it while we answer a few more questions. So next question here is going to be from Malcolm. Malcolm would like to know, what is the viability of SARS-CoV-2 on surfaces? So my last understanding was just that NEJM article that came out a while ago. I haven't seen anything since then that at least stands in mind. Have either of you found anything since that point?
No, I mean, relatively early on, I mean, that's already a few months ago. I think it was New England Journal of Medicine or so. They had like a list of different kind of surfaces. What was it? Aluminium, paper, and so where they compared the viability. I did not see any more of that work recently. Also, as some of the focus, I mean, the CDC toned down a little bit on the surface issue. For the air issue too, there's very little on viability. There's just 1 or 2 studies that are out there in the US by national labs or a military lab that looked and saw that with solar irradiation outside, it's probably viability might be down to 10-ish minutes. But then without the lights, the viability in airborne particles, it's longer. But overall, for both surfaces and aerosols, the number of studies is just very limited because very few institutions will get approval to do these things. For aerosol, you need to aerosolize the airborne virus, and you don't get approval to do these kind of things, or nobody wants to do it because after all, as researchers, you're in the first line then to get it.
Yeah, in the Science Friday, Ira Flato was interviewing the researcher and said, how do you replicate this? And the PI said, you know, the grad students really don't want to contribute actual poop to these studies on how to flush better. So we developed a material that was similar enough to it. So I think all I would add to what Pierre is saying, which was well covered, is the studies, as I recall, the harder surfaces, so stainless and aluminum and the like, porcelain, etc. The less porous surfaces like those, it tends to stay viable longer, but it's still only a few days. And if we're on the subject of bathrooms, typically most bathrooms are getting at least 1, if not 2, good disinfections with strong enough disinfectants that I'm not too worried about that, except that I don't want to get anything. I don't want to get E. coli. I don't want to get the norovirus or something like that. So I'm going to wash my hands, each and every time that I use a bathroom, and be careful of those doorknobs and other surfaces like we've been talking about. And for Pierre and I here in the Valley of the Sun, grabbing a grocery cart that's been sitting outside in front of fill in the blank grocery store for more than a few minutes, you probably don't have to worry about anything. Between the heat and the UV, it's probably killed anything that was there.
Yeah. And just to speak quickly to Marcus's point, I am not a virologist, but I did do quite a lot of work with virus in my time at Boston Children's Hospital, doing some stem cell biology and things like that. Certainly I'd expect that virus in just a vacuum would be longer lasting in -80 freezer than on a surface, but definitely those do seem to really need to be coddled pretty aggressively when they are frozen and thawed to remain viable, and also in any manageable large amount. So hopefully -80s will not suddenly become a major source of risk there, but I'm sure we'll hear about it if they do.
Yeah, but again, I keep referring to this FAQ list because I really did love it and read the whole thing. They even talk about this, and that's how samples are kept viable, is in these -80 freezers.
Yep.
So yeah, absolutely, it's something to be concerned about. Rabies can survive for years in freezers. That's been tested pretty well. So I think people are thinking exactly in the right terms. What are the risk factors for this specific example or instance?
Yeah, absolutely. So going on here, we have just a quick question. I think this is a common one, again, to build off jet dryers in our conversation about hand dryers. Would there be situations like where, sorry, let me rephrase this. Denise asks, what is your recommendation on jet air dryers, which we've already covered, but should we be encouraging the use of these and using paper towels, or are there certain facility types where jet dryers are prohibited? So I think maybe to distill and avoid us talking over the same points, would you recommend paper towels over hand dryers generally? Is that something that you're sort of thinking about? I know that we spoke earlier about the benefits of paper towels acting double duty, not just reducing maybe aerosolized particles or droplets, but also being used to hygienically touch surfaces as you exit the bathroom, especially in bathrooms that have pull handles as you exit.
I agree with what you said, Matt. I don't think I have anything to add to that. I don't know if Pierre does.
Yeah, the same. I mean, I don't think you necessarily. I mean, you really have to forbid the jets, but probably in the current situation, the towels are more. You get more benefit than at the expense of the environment. But I mean, in the current situation, you might want to get for the health benefit.
Great. Sorry, just looking through here for another question to go ahead and get to. I know there are a lot down at the bottom that have been asked recently, so I'm kind of looking around in there. So if either of you see anything that calls out to you, feel free to highlight that. But in the meantime, just kind of let people keep participating. It's really nice to see all of these messages here on our little anonymous advice wall.
It's been an interesting conversation, as I think a lot of people are reflecting. And I'm really glad that, that people are enjoying the conversations in particular here. That's good to know. See, you can talk about poop in a really great, fun way, right?
Oh yeah, certainly.
Yeah, so I mean, one of the questions seems to be about the testing of fecal matter and of wastewater or so. It can definitely be done. My university does it, like many universities do it, but I couldn't tell you the price for the test, just because, I mean, it's typically research facilities that do that. My university does it for the city in which the university is located. So they even have a dashboard of the local wastewater and COVID occurrence in the local wastewater. And so, but I wouldn't know the price of the individual test, nor the frequency that you really need to have a meaningful thing for that. But I think right now there's also a lot of government funding or so out. So some places have grants to do monitoring, and they might be willing to take on samples or so. And then a related question was on the risk to the municipal workers. Well, yeah, I mean, as people monitor, they know that this is there, and they know there is a risk of aerosolization. And years ago, I was involved in a study that showed, our focus was on pharmaceuticals and hormones, and we showed if they were in the wastewater, they actually got aerosolized on a normal wastewater treatment plant. You have aeration basins or so, and it's very well documented that even on the fans of the facility, in respiratory aerosol, you could find traces of all kinds of pharmaceuticals, hormones, and so clearly from the wastewater. But here, I think dilution and concentration is a big issue, and will protect the municipal workers and the wastewater workers. Many of them already wear, particularly in confined environments, they already wear protection because I mean, there's all kinds of stuff in there, and it's known that it's getting aerosolized.
Certainly. And
yeah, I was just doing a quick search online and I chose a lab that I know of. I don't want to give any names. It's unfair to other labs as well, but just a general lab that I know of that has a bunch of offices. And SARS-CoV-2 virus by RT-qPCR, presence absence, 1 week turnaround is under $200. So I think if you look at the journal articles that go into this, you can see what the researchers are using. And I think that's a really good way of really starting to think about this and wrap your brain. If you're looking to do testing, I think you can also then talk to the labs that you would normally use, commercial labs. I encourage people to look in-house at their own researchers and see a couple of things. One, at the very least, what do they recommend? What do they think is going to be best for your situation? Anytime you want to do some type of research, most researchers are more than happy to help. And yes, it is possible that they may be able to do it for you, but as Pierre's saying, they're doing research and they're not there to do commercial, but you never know what an in-house for your own institution may do. And then I think you can start to figure out and develop a really good, I always encourage, no matter what you're doing, develop a good sampling and analytical plan that lays out all of this, all of the reasons. What are you collecting? Why? What are the results that you're looking for? How are you going to make decisions based on those results, et cetera? And there's really good ways of developing that plan before you get into sampling, and then you have data that you don't know what you're going to do with it.
Wow. John, Pierre, thank you so much for your expertise. This hour and 15 minutes really flew by. I want to thank both of you for your time and all of the energy that you put into having this conversation be possible. A huge thank you to our attendees for asking so many questions and for answering each other's questions and all the ones that we weren't able to get to. I'm sure that if everybody were able to speak right now, you hear a really big level of applause for both of you. And I just wanted to kind of summarize here quickly, looking at all of these different posts and advice for our early pandemic selves. Just remember to be kind to yourself and a little extra patient with yourself and with others around. We are about to enter the winter for many of us, and things are going to change in ways we don't expect and in ways we do expect. So fill up those tanks, get out for walks, try to find silver linings, and maybe don't worry about bathrooms too much. I hope that everybody has a great day. Thank you all for joining us. I hope to see you again in a few weeks to talk about getting involved in, helping lend your expertise to decision making that happens across other aspects of your organization. And have a great long weekend, and I will see you next time.